In this lesson, we'll be multiplying polynomials. In an earlier lesson, we learned the product rule for exponents, which states that if you're multiplying variables that have like bases, then you add the exponents. So in this example, -3 times 5 is -15. X to the first times x to the fourth is x to the fifth, and y squared times y to the fifth is y to the seventh. So earlier we were actually multiplying a monomial times another monomial when we learned the product rule for exponents. Let's do another example. Once again, we're multiplying a monomial times a monomial. 8 times -4 is -32. A to the fourth times a to the first is a to the fifth. B to the fifth times b to the eighth is b to the 13th. And notice there's no c in the second monomial, so there's nothing to multiply that c by. In this example, a monomial is being multiplied by a binomial. So we'll continue to use the product rule for exponents, but we'll also need to use the distributive property. 2x cubed times 5x squared is 10x to the fifth, and 2x cubed times -6 is -12x to the third. In this example, a monomial is being multiplied by a trinomial. So once again, we're going to use the distributive property. -7p squared times 2p squared is -14p to the fourth. -7p squared times +5p is -35p to the third. And -7 times -3, -7p squared times -3 is +21p squared. So let's try two examples on our own. In this example, a monomial is being multiplied by a trinomial. So let's go ahead and distribute the 7x cubed. 7x cubed times x squared is 7x to the fifth. 7x cubed times -4x is -28x to the fourth. And 7x cubed times 5 is +35x to the third. Now, a monomial is being multiplied by a binomial. Distributing the -4v to the second, we have -4v to the second times -2v squared, which equals 8v to the fourth. And -4v squared times -9 is +36v to the second. In this example, we're multiplying a binomial times a binomial. So in this example, actually, we're going to have to use the distributive property twice. First, we're going to have to distribute the 2x to the second binomial, and then we'll need to distribute the 3 to the second binomial. So 2x times 5x is 10x squared. 2x times -6 is -12x. Now distributing the 3. 3 times 5x is 15x, and 3 times -6 is -18. So now we have a 4-term polynomial, but notice the two terms in the middle are like terms, so we can combine those. -12x and +15x is equal to +3x. So our final answer is 10x squared plus 3x minus 18. There's another way to remember how to multiply a binomial times a binomial. We can use the acronym FOIL. The F represents the product from the first position, so that would be the 2x times the 5x. The O represents the product from the outside positions, so there we would be multiplying the 2x times the -6. The I represents the product from the inside positions, 3 times 5x. And the L represents the product from the last positions, 3 times -6. Notice it's helpful if you do the first and the last on top, and the outer in the inner down below. So notice 2x times 5x is 10x squared. Doing our outer, 2x times negative 6 is negative 12x. Our inner, 3 times 5x is 15x, and 3 times negative 6 is negative 18. Then we see that negative 12x and positive 15x are like terms, so we can combine those. Our final answer is 10x squared plus 3x minus 18. Let's use the acronym FOIL to help us remember how to multiply these two binomials. 3x times 4x is 12x squared. Now we'll do our outer. 3x times negative 1 is negative 3x. Multiplying our inner terms, 4 times 4x is positive 16x. And then multiplying our last, 4 times negative 1 is negative 4. Now remember, we need to combine like terms if we have them. Notice negative 3x and positive 16x are like terms. That will give us 13x. And we'll drop down the negative 4. That 13x is positive, and we'll drop down the 12x squared. Let's do another example. Four x times 2x is 8x squared. Our outer, 4x times negative 7 is negative 28x. Our inner, negative 5 times 2x is negative 10x. And last, negative 5 times negative 7 is positive 35. First, outer, inner, last. Okay, our outer and our inner are like terms, so we'll combine those. Negative 28x and negative 10x is negative 38x. We'll drop down the positive 35, and we'll drop down the 8x squared. Sometimes when we're multiplying two binomials together, they take on a special pattern, so we end up with a special product. Notice these two binomials that we're going to multiply together. They only differ by their sign in the middle. We call these conjugate binomials. So we can still use FOIL to multiply these. 3x times 3x is 9x squared. Multiplying our outer, 3x times negative 5 is negative 15x. Our inner, 5 times 3x is 15x. And our last, 5 times negative 5 is negative 25. Now notice our like terms, negative 15x and positive 15x, when we combine those we get 0. So we're just left with 9x squared minus 25. Whenever you multiply two binomials that only differ by their sign, the product is going to take on this pattern. And we call that a difference of two squares. Because notice we have the subtraction sign in the middle, the difference. And then 9x squared is a perfect square because 3x times 3x is 9x squared. And 25 is also a perfect square because 5 times 5 is 25. So we call that a difference of squares. We can still use the FOIL acronym to help us remember how to multiply these two binomials. 4q times 4q times 4q is 16q squared. Our outer, 4q times positive 3 is positive 12q. Negative 3 times 4q is negative 12q. And negative 3 times 3 is negative 9. Once again, the 12q and the negative 12q equals 0, so we're left with a difference of two squares, 16q squared minus 9. In general, when you're multiplying conjugate binomials, the product is going to take on the pattern a squared minus b squared. Notice with these two binomials, they're exactly the same. So we have 3q minus 4 times 3q minus 4. And this will also take on a special pattern. We can still use FOIL to multiply these two binomials. 3q times 3q is 9q squared. Our outer, 3q times negative 4 is negative 12q. Negative 4 times 3q is negative 12q. And negative 4 times negative 4 is positive 16. So notice our inner and our outer are the same. And we add those up, and for our middle term we have negative 24q. So our final answer is 16q squared minus 24q plus 16. This special product is called a perfect square trinomial. Notice these two binomials are identical as well, so the result will be a perfect square trinomial also. We can still use FOIL to multiply. 2p times 2p is 4p squared. Our outer, 2p times 5 is positive 10p. Our inner, 5 times 2p is positive 10p. And then last, 5 times 5 is positive 25. Notice once again our inner and outer are exactly the same. We'll combine those because they're like terms. Drop down your positive 25 and drop down your 4p squared. So the resulting product is a perfect square trinomial. And notice, if you have a perfect square trinomial, the first term will be a perfect square, and the last term will also be a perfect square. Once again, we are multiplying two identical binomials, so our product will be a perfect square trinomial. We can still use FOIL. 2p times 2p is 4p squared. Our outer, 2p times 5 is 10p. Our inner, 5 times 2p is 10p. And our outer, 5 times 5 is 25. We can combine our inner and outer terms. 10p plus 10p is 20p. So the resulting product is 4p squared plus 20p plus 25. This is the form that you will usually see when you're multiplying two identical binomials. Make sure you remember that you are multiplying two binomials. You cannot just apply the exponent to the terms. So it's best to write it as 2p plus 5 times 2p plus 5. And then you can use the acronym FOIL to help you remember how to multiply. In general, a plus b raised to the second power will equal a squared plus 2 times a times b plus b squared. And a minus b, all raised to the second power, will equal a squared minus 2 times a times b plus b squared. Whenever you multiply two binomials together that are identical, the product will always take this general form. Notice in the a plus b raised to the second power, the operator in the binomial will determine the first sign of the trinomial. So here we have 3x plus 7 all raised to the second power. So let's go ahead and rewrite that as 3x plus 7 times 3x plus 7. And then we'll go ahead and just use FOIL to multiply. So f, 3x times 3x is 9x squared. Our outer, 3x times 7 is positive 21x. Inner, 7 times 3x is positive 21x. And last, 7 times 7 is positive 49. Let's combine our inner and outer terms. So our final answer will give us 9x squared plus 42x plus 49. Another example of a perfect square trinomial. Let's do one more. Here we have 2x minus 5 all raised to the second power, so let's go ahead and rewrite it. Two x minus 5 times 2x minus 5. Using FOIL, 2x times 2x is 4x squared. Outer, 2x times negative 5 is negative 10x. Inner, negative 5 times 2x is negative 10x. And last, negative 5 times negative 5 is positive 25. Remember, you can only use FOIL when you're multiplying two binomials together. So let's combine our inner and our outer. Negative 10x and negative 10x is negative 20x. Drop down the positive 25 and drop down the 4x squared. Another perfect square trinomial. This will be our final example. We're multiplying the binomial 4x plus 1 times the binomial 4x minus 1. Now don't get this one confused with the previous two examples, because remember, in the previous two examples, the binomials were identical. So try to recall what our special product will look like in this case. These are conjugate binomials. We can go ahead and use FOIL. F, 4x times 4x. Sorry, 4x times 4x is 16x squared. Outer, 4x times negative 1 is negative 4x. Our inner, 1 times 4x is positive 4x. And then last, 1 times negative 1 is negative 1. Now notice the signs of our inner and outer. We have a negative 4x and a positive 4x. When we combine those, we get 0. So our resulting product is 16x squared minus 1. Remember, this special product is called a difference of squares.